Today I am going to explain about Microcontroller Module 1 CSC 4 SEM VTU BCS 402 code subject. First we have discussed about the Module 1 important questions. The first question is difference between the microprocessor and microcontroller. Microprocessor and microcontrollers. The microprocessor is the heart of a computer system and microcontroller is a heart of a embedded system. And microprocessor is just a processor, memory and input-output components have to be connected externally. In microcontroller has an external processor along with the internal memory and input-output components. And microprocessors are memory and input-output has to be connected externally and the circuit becomes large. And microcontrollers are memory and input-output presence is internally, the circuit is small. And microprocessors cannot be used in compact system and hence insufficient. Microcontroller cannot be used in compact system and hence it is an efficient technique. Cost of an entire system is increases in microprocessor. Cost of an entire system is low in microcontrollers. Due to the external components and entire power consumption is high and hence it is not suitable to use with devices running on stored power bikes in batteries in microcontrollers. And since external components are low, total power consumption is less, can be used with a device running on stored power like batteries in microprocessors. The most of the microprocessors do not having power saving features. The most of the microcontrollers having in power saving modes like idle mode and power saving mode. This helps to reduce the power consumption even further. And then since memory input output components are external and each instruction will need to external operation, it is relatively slower. Since components are internal, most of the operations are internal instruction and speed is fast. Microprocessors having a less number of registers hence more options are memory based. Microcontroller having a more number of registers hence more programs is easier to write. Then second question is the risk design philosophy based. The question ಹೆಂಗೆ ಕೇಳ್ತಾರೆ ಅಂದರೆ explain briefly the risk design philosophy. The answer is first we have to discuss about definition of risk design philosophy. Risk design philosophy is aimed at a simple but powerful instruction that execute within a single cycle at a high clock speed and concentrate on reducing the complexity of instruction performed by the hardware, provide a greater flexibility and intelligence in software rather than hardware. Then the RISC philosophy is implemented to the four major designing rules. The four major design rules are instruction, pipeline, register, load store architecture. The first one is instruction. We have to discuss the first instruction. RISC as a reduced number of instruction classes. These classes providing a simple operation so that each is executed in a single cycle. Each instruction is fixed length to allow the pipeline to fetch the future instruction before decoding the current instruction. Then second one is pipeline. The process of instruction is broke down into smaller units, means it's broke down that can be executed in parallel by pipelines. And then third one will be register. Register is a third type of a RISC philosophy. RISC machines having a large general purpose register. Set any register can be contain either data or an address. Then load store architecture. What is a load store architecture means the processor operates on the data held in register. Separate load and store instruction transfer data between the register, bank and external memory. Then we have to define the design rules allow RISC processor to be simpler. The score can be operate higher clock speed. Then we have to draw the figure RISC and CISC. The figure will be shown in the below. See, the CISC and RISC only one difference will be there. The greater complexity is ಪ್ರೊಸೆಸರ್ ಹತ್ರ ಇರುತ್ತೆ. ದೆನ್ ರಿಸ್ಕ್ ಹತ್ರ ಗ್ರೇಟರ್ ಕಂಪೇರ್ಡ್ ಕಂಪೈಲ್ ಹತ್ರ ಇರುತ್ತೆ. ಇಷ್ಟೇ ಇದು ಟೂ ಡಯಾಗ್ರಾಮ್ಸ್ ಇರೋದು. ದೆನ್ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಏನಪ್ಪ ಅಂದರೆ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿ ರಿಸ್ಕ್ ಆ್ಯಂಡ್ ಸಿಸ್ಕ್. ಆ ರಿಸ್ಕ್ ಆ್ಯಂಡ್ ಸಿಸ್ಕಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಕೂಡ ಬರಿಬೋದು, ಅದೊಂದು ಡಿಫ್ರೆನ್ಸ್ ಆಗುತ್ತೆ. ದೆನ್ ಎಂಪಥೈಸಸ್ ಆನ್ ಕಂಪೈಲರ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ. ಸಿಸ್ಕಲ್ಲಿ ಎಂಪಥೈಸಸ್ ಆನ್ ಪ್ರೊಸೆಸರ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ. ಸಿಂಪಲ್ ಬಟ್ ಪವರ್ಫುಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಇನ್ ರಿಸ್ಕ್. ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಆರ್ ಮೋರ್ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಇನ್ ಸಿಸ್ಕ್. ಎಕ್ಸಿಕ್ಯೂಟೆಡ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಇನ್ ಸಿಂಗಲ್ ಸೈಕಲ್. ರಿಸ್ಕ್ ಅನ್ನೋದು ಒಂದು ಸಿಂಗಲ್ ಸೈಕಲಲ್ಲಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗುತ್ತೆ, ಬಟ್ ಸಿಸ್ಕು ಟೇಕ್ ಎಸ್ ಮೆನಿ ಸೈಕಲ್ ಟು ಎಕ್ಸಿಕ್ಯೂಟ್. Risk instructions are fixed length, CISC instructions are variable length. Having a large set of general purpose registers in RISC, having a limited set of general purposes in CISC. Any register can contain either data or an address in rails. Dedicated register are specific purpose in sys. Separate load and store instruction transfer data between the larger and external memory in rails. Move instruction can be used to transfer between the register and memory in sys. Then go through the ARM design philosophy. The ARM design philosophy important question number to explain briefly ARM design philosophy ಅಥವಾ ರೈಟ್ ದಿ ಫಿಸಿಕಲ್ ಫ್ಯೂಚರ್ ಆಫ್ ಆರ್ಮ್ ಪ್ರೊಸೆಸರ್ ಈ ಥರನೂ ಕೇಳ್ತಾರೆ ಎರಡಕ್ಕೂ ಒಂದೇ ಆನ್ಸರ್ ಏನು ದ ಫಾಲೋಯಿಂಗ್ ಆರ್ಮ್ ಡಿಸೈನ್ ಫಿಲೋಸಫಿ ದ ಆರ್ಮ್ ಪ್ರೊಸೆಸರ್ ಹ್ಯಾಸ್ ಬೀನ್ ಸ್ಪೆಷಲಿ ಡಿಸೈನ್ ಟು ಬಿ ಸ್ಮಾಲ್ ರೆಡ್ಯೂಸ್ ಪವರ್ ಕನ್ಸಪ್ಷನ್ and extended battery operation essential for such mobile phones and personal digital assistants. High core and second point is high core density is major requirement since embedded system have a limited memory due to the cost and physical size restrictions. And high core density useful to application that have a limited on board mobile such mobile phones. Then third one is embedded systems are price sensitive and used to low cost memory devices. And fourth one is another requirement is to reduce the area of the die taken up to embedded processor for a single chip solution. The smaller area used by the embedded processor, the more available space for specialization peripherals. And fifth one is the ARMS has incorporated hardware debug technology within the processor so that the software engineers can view the happening while processing executing code. Then instruction set for embedded system ಟಾಪಿಕ್ ಮೇಲೆ ಬರೋ ಕ್ವಶನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಏನಪ್ಪ ಅಂದರೆ ವಾಟ್ ಆರ್ ದ ಸೈಲೆಂಟ್ ಫೀಚರ್ಸ್ ಆಫ್ ಆರ್ಮ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಸೆಟ್ ಆರ್ ಸೂಟಬಲ್ ಫಾರ್ ಎಂಬೆಡೆಡ್ ಅಪ್ಲಿಕೇಶನ್ ಅನ್ನೋದು. ಅದಕ್ಕೆ ಆನ್ಸರ್ ಏನಂದರೆ the following ways to make a ARM instruction set suitable for embedded application. We have to discuss about the variable cycle execution for certain instruction, inline barrel shift loading, more complex instructions, and then thumb 16-bit instruction set, conditional execution, and enhanced instructions. First we have to discuss the variable cycle instructions, certain instructions. ಇದು ಏನಂದರೆ ನಾಟ್ ಎವರಿ ಆರ್ಮ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಎಕ್ಸಿಕ್ಯೂಟ್ಸ್ ಇನ್ ಎ ಸಿಂಗಲ್ ಸೈಕಲ್. ಆ್ಯಂಡ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಏನಪ್ಪ ಅಂದರೆ ಲೋಡ್ ಸ್ಟೋರ್ ಮಲ್ಟಿಪಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ವೇರ್ ಇನ್ ಎ ನಂಬರ್ ಆಫ್ ಎಕ್ಸಿಕ್ಯೂಷನ್ ಸೈಕಲ್ಸ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ಎ ನಂಬರ್ ಆಫ್ ರಿಜಿಸ್ಟರ್ಸ್ ಬೀಯಿಂಗ್ ಎ ರಿಜಿಸ್ಟರ್ ಟ್ರಾನ್ಸ್ಫರ್. Then second one is inline barrel shifter leading to more complex instructions. Means the inline barrel shifter is a hardware component that processes one of the input register before is register an instruction that expands the compatibility main instruction improve the performance and code density. Then go to the third one, thumb 16-bit instruction set. Means the ARM enhanced processor code adding in second 16-bit instruction is called thumb that permits ARM core execute either 16-bit or a 32-bit instruction. Then fifth one is conditional execution. The instruction only executes when specific condition has been satisfied. Future improved performance, code density, reducing branch instructions. Then enhanced instructions. What is enhanced instructions means? Then enhanced digital signal processors